Today I would like to present the done work according to the topic toward classifying HTML embedded product data based on the machine learning approach. According to this work, I would like to present the relevance of this work, challenges which we face, background, research questions, experiment description, and the result which we get. So as a result, we got the conclusion which is presented on this presentation. So according to the relevance, nowadays, based on the research done by the Department of Commerce Data of US, we know that the profit of electronic sales become higher than the offline sales. According to that research, the profit increased from the 34% similar time 1 year before. Therefore, the number of products sold online and the number of available data is increased. As a result, each marketplace adds a product in itself manner, and the result, the data is represented differently. Therefore, we face with some challenges. According to that challenges, we get a large amount of data, which is very difficult to work with. We understand that the bad data cleaning affects the algorithm performance. Also, it's complicated to choose the correct categorization method, digitalized method for their available data. Background, according to the background, we had, as an example, we had 3 different marketplaces which have different ways to publish the new product to their platforms. We get the available data from that marketplaces and store that data to the JSON format. For this data, we applied machine learning algorithms and it's possible to build the product which can recommend the correct categorization for the added data. So we had the next research questions. How well known machine learning algorithms perform for the classification tasks based on the text data? How to select features from the dataset which can be used for the product classification? What influence on the machine learning performance for the provided data? So according to the problem state, so we have their learning classification function, we had the number of product titles, we had the corresponding categories. So our goal was to learn a linear classifier model for their weight vector that can minimize the misclassification error on the training corpus. The next algorithm is presented. According to the SVM and Canon algorithm, the Canon algorithm classifies an unlabeled test samples based on the majority of similar sample among the K-Nearest neighbors that are closest to the test sample. So K is a number of nearest neighbors of the test data point. The distance between the test sample and each of the training data samples is determined by the specific distance measures. SVM finds a hyperplane to separate the points of different classes in n-dimensional space. The distance between the hyperplane and training data point is called the functional margin, which is used to indicate the corresponding of classification result. As a maximum margin classifier, the hyperplane obtains in SVM with the highest function margin to closest training data point, provides the best data separation. The nearest data points are called support vectors. So we build the next classification pipeline. As I said, we got the data in the JSON format. We converted the data to CSV format because machine learning algorithms applied for the CSV format. So we made the data processing. We analyze the input data, select the input parameters, clear the input data. Then we construct the classifier, which means that we divided the set into test and validation, convert input parameters to the numerical format, search for optimal parameters, then we train the model. According to the trained model, we applied the validation for that result, and each result is saved to the Excel format. We build the next architecture. So you can see that we have this is a global architecture which can be extended. Right now, what was done, we made the data processor, which is presented in the center of the screen, and we get the data cleaning. But for the future work, we can develop the web client and store the all information to the PostgreSQL server. For this product, we build the next classes. We build the data processing, we build the modeling, which includes SVM and KNN model, and we build the validation class. So our experiment description. What we had the data set which had 323 unique brands. We had 41,000 of numbers. We had 17 columns. You can see that the example of cleaned tables. For example, we have brands on the left side. You can see the list of brands. You can see the titles which you had, and you can see the description. So this data was cleaned. On the right side, you can see the list of columns which we got. So we have no title data, we have brand, category, cluster ID, and so on. On the left side, also you can see the unique brands, but this not all of that brands, because we have 323 brands. So also you can see that we lost almost 40% of the data because we cleaned the data. For example, initially we had 41,000 of data. Then we removed the stop words, then we removed the null rows, then we removed the brands accurate less than 5 times, and then we cleaned the non-English lines, because we are working only with English lines. Our dataset had Polish, Spanish, and so on. So as a result, we got only 10,000 data. So I would like to present more details about the done pipeline. What was done? We export the data analysis. We done the exploratory data analysis. We select the features based on the exploratory data analysis. We made some pre-processing. We made some data transformation, which I mentioned. We removed topic natural words such as article, prepositions, and so on. We applied the word stemming. We applied the classification models, which is in our case, which is SVM and KNN, and then we analyze the results. So as a result, we got the next things. We decided to make an experiment for different parameters, C parameters for the SVM algorithm. So you can see that for this experiment, the best C parameter which is 0.1 to 5, which gets the highest F1 score, which is almost 76%, and which have, in our opinion, which performs the best. So we got only 21% of misclassified data, which is good. For Canon results, we made different experiments. We analyzed different vectorization methods. We applied count vectorize, we applied hashing vectorize, we applied TF-IDF vectorization method for different numbers of data. You can see that we applied from 150 to 10,000. And we applied different metrics, Euclidean and Gaussian. According to these experiments, we got the highest result, which is 0.73%, which is also good, but you can see that it's less than for SVM. So, as a result, in order to compare, we build this diagram. So for SVM, you can see that the execution time is grows according to the C parameter. For our experiments, as I mentioned, the best F score is 0.76%. For C parameter equal to 0.125, and which perform with 310 seconds, which is approximately 5 minutes. Canon perform faster, but has some difficulties with categorization. F1 score is lower for Canon, but not so much. So you can see that the best result is for TF-IDF vectorization method, and but you can see that the execution time is grows according to number of features which we applied to the Canon algorithm. So, according to the conclusion and the future work, SVM has the best result, as I said. The macro means for the F1 score is 76% with C equal to 0.125. Calculation time for the method is 310 seconds, which is approximately 5 minutes. Canon model has the macro means which is equal for 73%. Execution time is equal to 10 seconds, so which is much higher, which is much lower than for SVM, and it's according to the TF-IDF scale methods and closing metrics. According to the future studies, we would like to improve the model, and we develop the next future steps, which is get more data for the test models. I think that 10,000 data is not enough for evaluate the good performance of these models. Implement the algorithms for automatic search of optimal parameters. Prepare the developed models for integration with e-commerce stores. So, we built a good experiments, we made the conclusion, and we analyze the future studies. Thank you for your attention.